Hello. In this presentation, we will be covering the separation work for the energy balance covered in ME 490 Sustainable Energy Applications. First, we will talk about what the separation work is, and then we will talk about the methodology and equations of finding this, and then we will look at a plot and go over the results when we plot the separation work versus a temperature range. To find the separation work, we first start with this first equation, which is the separation work reversible, and we take the number of moles times the universal gas constant, which is 8.314 times 10 to the negative third kilojoules divided by the quantity of kilomoles times Kelvin. Next, we multiply that by the reactor temperature in Kelvin, and then we multiply it by this quantity where Ya is the mole fraction of the first substance, and then Yb is the second mole fraction. Then to find the actual work, we will multiply the separation work by eta, which in this case, eta is 10%. Now we could see our results. For our equations, we are given that we are getting 1 mole of H2 out for every 9 moles of the other products, and this reactor is running at a 10% efficiency. The temperature range we use is 0 to 2300 Kelvin, and if you look at this graph, you could see that there's a linear relationship for reactor temperature and the actual work, and we can expect this relationship from how we set up our equation with T as a direct relationship. Some applications of this are gas separation and hydrogen solar fuels, but in some situations you wouldn't want to use this as it might not be practical, or the reactor temperature might be too high to be able to forego this experiment. In this presentation, we went over what work separation is, the equations and methodology to achieve that, and the results when a temperature range and a 10% efficiency is plugged in.